The pursuit of new chemical compounds has always proved to be a fascinating journey, and chemical invention has created several major technological steps forward, though not, however, without unpredictable and dire consequences. Back in 1974, two American scientists published a theory which claimed that the apparently harmless gases used in refrigerators and spray cans were destroying the protective and delicate ozone layer in the atmosphere. Should the theory prove to be true, it would not only mean a substantial increase in the numbers of those contracting skin cancer, but also have completely immeasurable consequences for food production. So, for several years, scientists worldwide were searching for proof of the validity of this theory, without success. Nevertheless, should the theory be proven, mankind would face yet another fatal dilemma.
This little can with a button on top is used in hundreds of ways to make your life easier and more pleasant. It contains an aerosol. And of course you know what this is. Now what do these two things have in common? Well, the answer is Freon fluorinated hydrocarbons, used as cooling agents in the coils of your refrigerators and as propellants in aerosols of all kinds. This beaker contains liquid
The history of
Freon,
Freon, or CFC gases, began in the 1920s with the mass production of refrigerators, in order that foodstuffs could be both safely stored and for longer periods.
Before the era of refrigeration, lots of food would spoil, and so food would be wasted. People would get basically upset stomachs, more serious effects from food poisoning. So the advent of refrigeration was absolutely critical.
Although the very first refrigerators which came on the market soon proved to be popular, they were also a health hazard.
The refrigerants that were first used were very dangerous. They were ammonia, they were sulfur dioxide, they were chemicals that could be directly toxic or they could damage food. There were many stories in the local newspapers about families that would die from a leaking refrigerator, or about health problems such as breathing problems that would be made worse. There were fires and explosions. So it was a very dangerous time in refrigeration and air conditioning.
Manufacturers of refrigerants, such as the cooling division of General Motors, rushed to develop a safer compound, with their most noteworthy scientist Thomas Midgley discovering a refrigerant in 1930 which was trademarked as Freon. It was both non-flammable and non-toxic, and to prove his point, Midgley inhaled Freon and then afterwards blew out a candle, much to an impressed American Chemical Society assembly.
Sometimes they would say safe as milk, that it was perfect in every way and that it was a miracle chemical, and it was proof that chemistry could solve any problem that people would have.
The application of CFC gases in refrigerators became a huge success, and their usage quickly spread to dishwashing sponges, foam rubber, foam insulation, and aerosol cans.
Today, Freon, made by DuPont, is used as the power plant in many, many types of aerosol products. They make your life easier, safer, more pleasant. Better things for better living through chemistry.
By the 50s and 60s, the average American household had around 40 different assorted aerosol cans in use: hairspray, insecticides, paint sprays, etc., such that the consumption of CFCs emitted into the air rocketed to almost 1 million tons a year. But the question was, where did they end up? English scientist James Lovelock resolved to measure the level of CFCs in various parts of the world, and developed an electronic instrument capable of measuring microscopic concentrations of CFC, down to 1/1,000,000th.
For 30 years, CFCs were put into the atmosphere and no one bothered, or could indeed, measured them in the small quantities were there. And then Lovelock came along, and he was able to make enough measurements around the world. He actually went on a cruise to the Antarctic and back, measured the latitude gradients of all the CFCs, which of course had never been released in those days in the southern hemisphere, and it was possible to do some sums, which very crudely interpreted said 99% of all the CFCs ever released are still in the atmosphere.
When the American scientist Sherwood Rowland read about Lovelock's measurements, he and colleague Mario Molina decided to investigate what happened to these stable gases and developed a theory that changed our view of the world.
I knew from the experiments that we were doing in the late 60s and into the 70s that chlorofluorocarbons could be decomposed if there was just enough energy about them. So when you read that Lovelock had detected these in the atmosphere, the question then came up, I wonder what happens to it.
Rowland and Molina concluded that the gases rise slowly up into the stratosphere, the upper layer of the atmosphere, where they mix with the ozone layer, the protective shield against the sun's harmful ultraviolet rays. And here, the sun's rays liberate chlorine from the CFC, which in turn then attacks the ozone before breaking free again, and thus a chain reaction has begun.
On the average, you lose about 100,000 molecules of ozone for every chlorine atom you produced. And when you go back to 1 million tons of chlorofluorocarbon released in the atmosphere, roughly, every year, and they're talking 1970s, and then you multiply it by 100,000, that begins to be an amount that is important on a global scale.
Rowland and Molina calculated that if the production of CFCs continued to rise at the same rate, the gases, which by 1995 would have caused a global ozone depletion of 7%, would by 2050 have destroyed somewhere between 30 to 50%. An alarming calculation indeed, because it meant that yet even more of the sun's harmful ultraviolet rays would reach the Earth's surface and would affect both vegetation growth and cause a marked rise in skin cancer.
Your first reaction is, somewhere we've lost a factor of 1,000, so we better check this calculation, and we did and realized that we hadn't. So at the American Chemical Society meeting in September of 1974, that's when I said that in press conference that we think CFC manufacture and release of CFCs should be stopped. Oh, and that put the fat on the fire.
Rowland and Molina's sensational theory hit the front pages of newspapers all round the world, beginning in America, where the New York Times in September 1974 warned that spray cans posed a threat to the Earth, and the Philadelphia Inquirer pointed out that the Earth would be destroyed, not with a bang, but with a quiet pfft. The CFC industry was displeased with Rowland and Molina's theory, to say the least, and certainly not about an increasing demand to ban CFCs in aerosol cans, because production had mushroomed into $1 billion industry, which employed over 500,000 people. To counteract the situation, the world's largest manufacturer of CFC gases, DuPont, placed advertisements in major American newspapers and magazines which declared, "Aerosol products suffer under a cloud of presumed guilt. We believe this to be unfair." The CFC industry then organized a month-long lecture tour by critics of the ozone theory. One of them, British scientist Richard Scorer, accused Rowland and Molina of being doomsday prophets, and in the periodical Chemical Week belittled their theory as nonsensical rubbish. And in the following years, the CFC industry spent millions of dollars ramming home the simple message that the depletion of the ozone layer by CFC gases is only a theory. One of the few places where the ozone layer of the stratosphere has been measured is from the British station of Halley Bay at the South Pole. Although changes have not been ascertained, the theory still causes concern.
In those days, there were very few people who understood ozone in any real way, or who actually made measurements and so on and so forth. I mean, it sounded really rather alarming, but it was so difficult to actually get a handle on what was going on. Computer modelling was in its infancy. Chemical calculations were really quite complicated. You sketched things on the back of an envelope and you scratched your head.
Many of the skeptics said, until you can demonstrate that ozone is being lost, why should we believe this theory? So NASA put together a very strong research program. It was a research program where we measured ozone in the atmosphere, and we had satellites and ground-based observations. We tried to understand the chemistry in the laboratory, and effectively we put together models of how did the atmosphere work. So we had a very comprehensive program.
Before dawn this morning, this balloon was launched from New Mexico. It carried scientific instruments into the stratosphere. A U-2, the high-altitude one-time spy plane, has been sampling ozone levels for months. Sounding rockets, launched from Virginia, also are being used. And satellites are sending back observations from space as part of the drive to find out how dangerous the situation may be. But government scientists say, despite the massive effort, it'll take a long time to come up with hard information.
The depletion of the ozone layer is still just a theory, and it may be a long time before we know for certain whether or not the Earth will be exposed to stronger ultraviolet radiation. Nevertheless, there is still great concern.
The public actually did get very, very concerned very quickly that indeed these fluorocarbons could actually have adverse health effects, i.e. cancer. If there's one word in the dictionary that scares the average person in America and in other parts of the world, it's the word cancer. So as soon as there was a link between fluorocarbons, the ozone layer and cancer, the public started to scream.
The American Environmental Protection Agency estimated that an increase in ultraviolet radiation would raise the number of skin cancer cases by 1 million a year, should the use of CFCs continue to increase. The EPA was also concerned that the radiation would weaken our immune system and thus increase the risk of infectious diseases. The American authorities reacted quickly and in 1978 banned the use of CFC gases in aerosol cans. The industry began research to find substitutes for CFCs. But following the ban on CFCs in aerosols, public debate died down.
In the United States, the EPA banned the uses, and a few Nordic nations banned uses successfully, but everything became quiet after that. And for the longest time, there were no scientific investigations, there were headline news, and the environmental NGOs were completely silent. Some research shows that the public thought that the problem was solved, that they thought that CFCs were just used in aerosol products and that they were banned. So in countries like the United States, people didn't believe anything was wrong, and they didn't have anyone calling them to action.
By the late 1970s, the use of CFC gases had fallen, though only to rise again, for the ban on CFCs in aerosol cans only had a limited effect and couldn't compensate for an increased use of refrigerators and foam insulation, about which no one seemed concerned, since it was still only a theory, and at that point in time, no one had been able to measure a depletion of the ozone layer or an increase in ultraviolet radiation. Britain's Halley Bay station at the South Pole has been measuring the ozone in the atmosphere since 1957. But it was not until the early 80s that scientists began to notice remarkable fluctuations in the ozone layer. Even so, they still found it difficult to believe what they were witnessing.
We had sort of measured slowly decreasing amounts of ozone over about 3 or 4 years. Well, then you've got an awful lot of checks to carry out. I mean, I tell people that it's all very well training young men, sending them 10,000 miles away to make measurements. When you see something strange, your first thought is, oh my God, what have they done? They must be doing something silly. So that takes a long while to go through. Convince yourself that the measurements are okay.
Joe Farman also wondered why NASA computers hadn't tracked the same ozone layer depletion over the South Pole, but they weren't programmed to deal with such substantial fluctuations.
NASA was monitoring the ozone layer from satellites that were thought to be much more accurate and much more global. But it turned out that NASA, in the programming of their data collection, were ignoring the very low and the very high readings for ozone. So they systematically ruled out considering the low ozone levels.
What you normally do is you say, well, I think I know how much ozone there should be there. But if it's outside of what is 95%, you reject it because it's probably an error, basically. And there's nothing wrong with that. What the scientists who made the measurements failed to see was at the beginning, when they first launched their satellite, maybe they were only losing 1% of their data. Then the next year it was 5% of the data. Then the next year they were throwing 20% of the data away. So year after year after year, they were losing more and more and more data.
After hesitating for several months, Joe Farman decided to publish the findings he made at Halley Bay. In just a few years, the ozone layer over the South Pole had been depleted by no less than 30 to 40%. His findings took scientists by surprise all over the world, because their consequences are far more serious than Rowland and Molina had predicted. There's a huge hole in the sky about the size of the United States, the blue area of the figure here.
It was electrifying. It was a totally startling event. It was vivid to the public. It's one of the images anyone would recognize. If you see a photograph of the Antarctic ozone hole, people all over the world in developed and developing countries can recognize that, because it was absolute proof that humans were capable of destroying the atmosphere. And this would be totally unacceptable, both in environmental and economic terms, to have these kinds of effects.
Joe Farman's discoveries still shock most of the world and strengthen international efforts to substitute the use of chlorine gases with less harmful yet more expensive compounds, and the industry speeds up its development of substitutes. But it has not yet been fully proven that it is CFC gases which are actually ruining the ozone layer. In March 1986, NASA sent an expedition to McMurdo on the South Pole to determine whether there was a correlation between the chlorine gases and the depletion of the ozone layer. But when the expedition reported back to an expectant public, the answer was hesitant.
McMurdo, this is NSF Washington. This is NSF Washington. Do you read me? Over.
Can you hear me at all?
Roger, David. We're getting you loud and clear now.
Could you tell us what your experiments have told you? Do you think that these chlorofluorocarbons are causing this depletion and the ozone hole that you are studying?
As I just said, we do not feel that we have established the cause of the hole at this time.
Scientists all around the world continue to search for an explanation as to what was going on in the upper atmosphere. And the following year, NASA sent out a new and bigger expedition.
What we desperately needed was someone to measure what I call a smoking gun, the chlorine monoxide free radical that was the one that was responsible for all the ozone loss. We then put a major expedition together that was located in southern Chile, Punta Arenas, Chile, where we flew balloons right up through the whole ozone layer to measure ozone, not only the amount of ozone in color, but exactly where it was. We had people that could make measurements in the atmosphere. We had people that could do what we call modeling. We had people that looked at the dynamics of the atmosphere. We had a DC-8 that also could measure with upward-looking instruments what was happening in the ozone layer. And we had a U-2, it was an ER-2, a converted spy plane, a U-2, where it could fly right directly into the ozone layer. So it really was a fairly unique expedition.
Whilst NASA's expedition was in Punta Arenas, an international body of delegates met in Montreal, Canada, to negotiate a treaty to protect the ozone layer. Several international meetings on the ozone layer had previously been held, but once the ozone hole was finally discovered, things really started happening.
At Montreal, there was a genuine change of heart of business. That business, I think, was persuaded at the meeting that something needed to be done. It was hard fought up to the last minute, but in the end a deal was made and these difficult terms were set, and there was a total celebration when it was signed, and a great joy, I think, among all the participants.
The Montreal Protocol is the first binding international agreement that obliges countries to halve their consumption of CFCs over 10 years. Historically, the agreement is unique in that it is yet to be firmly established that CFC gases actually deplete ozone. The politicians in Montreal would probably have taken even further steps if they'd had the same knowledge as the scientists in Punta Arenas.
Even though we were convinced as scientists that we now understood how and why ozone was depleted, we did not let the governments who were negotiating in Montreal know our results. If we'd have told the governments in Montreal that we have now proven that human-produced chlorine is destroying ozone, and they had put a big international framework together to regulate chlorine, and then 6 months later we found we made a mistake, we would lose all credibility.
6 months after the negotiations in Montreal, NASA published the conclusive proof of what it is that depletes the ozone layer.
The smoking gun that we found was effectively there was a perfect anti-correlation between ozone and chlorine monoxide free radical. That is to say, as we moved further and further into the ozone hole, the area of depleted ozone, we saw the ozone concentration go down, and we saw the concentration or the abundance of the CLO radical go up. So these experiments that we had absolutely demonstrated without doubt that it was the fluorocarbons we were releasing in the northern hemisphere were having a major effect on ozone over the South Pole.
NASA's expedition finally proved what Rowland and Malina had so rightly predicted 13 years earlier, and the two American scientists received the Nobel Prize a few years later. But is it only the specific climatic conditions of the South Pole that help cause a depletion of the ozone layer?
People still said, okay, you've now seen the Antarctic ozone hole, you've linked it to fluorocarbons, human activities, but we're not seeing observations anywhere else in the world. So the very next important issue was to reanalyze all of the observations of ozone across the world. Once we broke apart in the ozone trends by latitude and by season, now we suddenly saw there was ozone loss. That started to get people more worried because the ozone loss was occurring over the mid-latitudes and the high latitudes. That is to say, over America and over Europe. And that did strongly influence the next set of negotiations after the Montreal Protocol.
In the following years, there are ozone layer conferences one after another in Helsinki, London, and Copenhagen. And the developed world countries adopted a complete plan to phase out CFC gases and a number of other ozone-depleting compounds. However, one thing became more and more clear, that although the developing countries only use 1/10 of the world's total consumption of CFCs, they too need to be included in the phase-out plan.
Everyone realized that as India and China and other countries increased in wealth, the same products that use CFC in Europe and North America and Japan would use CFCs in China and India. So people realized that you could not protect the stratospheric ozone layer by eliminating use in developed countries. You had to also eliminate the use in developing countries.
In the early 1990s, the developed countries established a so-called multilateral fund in order to help developing countries phase out their production of CFCs and switch to less harmful substances. In the following years, almost $2 billion was spent in a gigantic reconversion process. China alone receives just under $500 million to phase out its production and storing facilities, thereby reducing its consumption of CFCs by 2/3. This is the first time that factories in third world countries have been shut down for the sake of the global environment. In just a few decades, the international community has succeeded in limiting the consumption of ozone-depleting gases by more than 90%, and new substitutes are presently in use. Only a few unsolved problems are left.
Basically, the ozone issue is yesterday's issue. We do need to get the final phase out of all of the chemicals that are controlled under the Montreal Protocol. There's a major effort going on to completely eliminate all the production facilities in the former Soviet Union countries where some of the black market was coming from. But to a first approximation, I think we can look back to say this is one issue that we have largely resolved.
The American Environmental Protection Agency estimates that the Montreal Protocol has prevented an explosive rise in skin cancer of about 2 million cases a year. But the consequences of the use of CFCs, which have already been emitted, will have to be faced for decades to come.
We still have the Antarctic ozone hole, and some years it's worse than others. It was among the worst of the years just last year. The best estimates are we could save the ozone layer within 40 or 50 years, but there are other calculations that it might be up to 100 years. Even with the complete phase-out worldwide, total compliance of every nation in the world, we're still facing 50 to 100 years before we get full recovery.
The atmosphere is still one of the sort of worst observed bits of the world, despite all the efforts to see it. It's a massively complicated piece of mathematics. You've just got to be humble and say global warming, for example. Well, there's some very simple physics at the root of it. Put in more radiatively active gases and you're upsetting the current energy balance. What's it going to mean? Well, it might mean the surface gets warmer, it might mean winds go up, it might mean there are more hurricanes, it might mean any of these things. We really have no idea which one of them is going to be right. So we just simply got to say, for heaven's sake, let's change the world as slowly as we can so there's some hope of catching up when we suddenly realise what's important and what's not. But to imagine there's an expert sitting somewhere who can answer these questions for you is nonsense.